Engine. I hope you enjoyed the last class where we looked at the basics of FlexBe. We looked at state. We looked at how to use the proxy publisher and the proxy subscriber cache. Yeah, regarding that, I have something new for you. From the creator of FlexBe. I just received a mail from him, and he's very how do I put it? he's he's very responsive, and if you send him a mail, you talk to him about anything, he's open to talk to you. To help address any questions you may have with FlexB. Well, there are some pointers he made regarding last week's video, which I'll make sure to pass it on over to you before the end of this class. I hope you're all ready, and I'll be sharing the project file. So make sure you have an account on the ROS Development Studio, and then click on the link in the chat so that you can copy the project into your page, and then we're going to be using that. So today's class is on Action Clients, as I mentioned last week, and then we also look at the autonomy levels in FlexBe. So without much ado, I hope everybody's clicked on that link. You have it loaded, and just fire up your ROS Development Studio. Today is going to be great, and then very brief, nothing extraordinary, but then everything practical. So without much ado, I'm going to share my screen, and then we'll get started with today's class since we have probably less than 1 hour. So here I go, entire screen, application window, and share. Okay, so live class 27. I'm going to open my project, and hopefully today there are no delays. All right, that's great because the internet connection here is awesome, 5G. Yeah. All right, so I'm going to restore my workspace, and if you also clicked on restore workspace, you have something like this with the ID already opened and terminals also open for you. But if you don't, you can go to the tools drop down, and then click on the shell to bring up the terminals, and then the ID to bring up this graphical interface you see over here. So as I mentioned earlier, this is a continuation of the previous class. So I would like to make the pointers I mentioned at the beginning. So here's what I want you to do. Go to the casting workspace. In the casting workspace, go to the source, and then we're using the same project we created. So Turtlebot underscore behaviors. In that also, we are going to go to the folder named Turtlebot underscore FlexBe underscore state. And in that same folder, you also go to the source in that folder. I know it gets confusing, but bear with me. All right. So this is what I wanted to bring your attention to. Let's double click on the go underscore forward underscore state. And you can click on this to hide the sidebar. All right. So it was regarding the use of a callback. Well, there's a much simpler way to do this without using a callback, since the proxy subscriber cache, as I was made aware, stores all this. It buffers all the incoming messages for you. So this is what we're going to do here. We're just going to do a slight implementation to show you how you could have used this class without actually writing a subscriber. So I'm going to comment out the subscriber section, where we set a subscriber and all that. And then I'm going to go into the execute function. So bear with me. This is where we're going to make our modifications. It's a very simple one, nothing complicated. So all what you're going to do here is you get the instance that we created earlier, the subscriber instance. So we do self.scan underscore sub, and then you do a half message. Previously we're checking if the data we're pulling into the self.data is none. So here you can just do hash underscore message. And then remember to pass in the topic, because you could have subscribed to more than one topic. So here we pass in self.scan topic. So what happens here is it'll check if there's a message, pertaining to this particular topic. If it has, then let's store that message. Let's get it. So we do self.data equals self.scan underscore sub again, and this time we're doing get underscore last underscore message. And the same thing as we did earlier, self.what, we pass in the topic. Which topic are we fetching from? You do this. And one thing you can also do is right now we're getting the message, but in order to prevent any failures with your project, I mean, when you come back, when the loop runs again from fetching old data, you can remove this data from the stack. So how do you do this? You just do self.scan sub, then you do something like remove last message. And also remember to pass in the topic self.scan topic. So just like that, we've removed the callback and then we've implemented, I mean, the FlexBe way of doing things without callbacks. You can still use the callback, but then this looks much more easier for very simple projects. Well, you can save that and test it. We'll be using this class, so we'll be seeing it in live action. All right, for today's class, let's go to the tools and then click on the Jupyter notebook because today's class is really brief. Well, it could be long depending on the interactions. Yes. All right, let's make this a bigger screen and then let's get started. So FlexBe Engine, this is the part 2 brought to you by the construct and I am Esin Guaco. Okay, so why this class? This class is, as mentioned earlier, this is the second class of the 3 live classes that we'll be doing. And to get you started with FlexBe, teach you the ins and outs of it. And this is a medium level class. What I mean by that is you should be familiar with ROS basics, you know how to create a package, launch file, publish and subscriber topics and all that. Great. So just in case you're looking at this class, just in case you have this notebook after this class, you can run this tab over here. You can run it to start playing the video, but I'm not going to do that because it will slow down our connection and that is bad. That is really bad for business. So today on ROS Live Class 27, what are we going to learn about? Well, today's class, we're looking at action clients and then autonomy levels in FlexBe. I kept the state lifecycle that we looked at from the previous class here just for reference's sake. So just in case you've forgotten how that works, you can do a little bit reading on this section to know that the on start is called on all states present in the behavior, same as on stop. It's called on all states present in the behavior. But aside that, on enter is only called when the transition is occurring into this particular state. And then on execute, runs like a while loop. Well, it runs like a loop and then it executes until an outcome is returned. Same for on exit. When we are leaving this state, we call the on exit event. So that's just a summary of the whole thing. So without much ado, we'll be looking at the class that we'll be creating today. It's called the 10_state.py. What is the logic for this class? Last week, we saw that when the robot moved a certain distance, when we had a set distance for it, right? So what is happening here is anytime it failed, we are going to do something. We are adding another state that makes the robot turn a certain angle. We will be inputting that angle so that it can avoid obstacles in a way. You get a gist as you move on. So what is with the class, the 10-state class? Well, the same as the previous class. It has the init, the execute function, and then we're implementing coding for events, the on enter, on exit, on start, and on stop. Let me check the comment section. Well, I think everything is. So if you have any problem as the class is being presented, you can just post it in the chat session and then somewhere along the class, I'll take a look at it and then do my best to answer it for you. So in the init, when we start the class, what we're doing is importing in the various libraries that we'll be using. So we have the FlexBe call. Remember, we are importing the event state. That's what makes a state a state. It's very necessary that you import this line over here. And then today, we are not using the proxy subscriber or publisher. We're using the ProxyActionClient. So that's what we are importing over here. And one more thing, I also created an action server just for this class. If there is enough time, I think I can also take you through the, but then we're importing the necessary stuff for the action server. So we remember we have the spin it's called a spin action server. So spin action, spin goal, spin result, and then the spin feedback. What this server does is it receives a goal. This goal is basically an angle like 90 degrees. And then it makes sure the robot makes that angle turns 90 degrees. If it fails, it'll tell us that the robot failed. If it didn't, then it returns a success, and then we move on. So what are we doing in the init function? Well, this class that we're creating also accepts two parameters. Remember, we looked at parameters last week. Parameters are just, let's say, variables that we can modify at runtime. So that's what we have here. We're taking in the turn angle and then the turn speed, which is t underscore speed. All right. Inside the init, we just do the usual initializations of the various variables, and then the action server that we're using is actually working on this topic. So Spain underscore server underscore capital X. All right. We move on to create a client. Just like the other classes that will be the other proxy classes, what you do is you pass in a topic and then the type of the action. So here we're passing in the topic, which we did over here, self dot underscore topic, and then we're passing in the action type. In this case, it's just spin action. All right, and then we have this variable that we'll be using to check if the initialization was successful or not. All right, so there's something different with how we did the other classes. What is different here is in the on enter event, this is what we're doing. That is where we create the goal, okay? And then we send the goal. And in the on execute, we check if the goal has returned. If it hasn't, then if there's a feedback, we report it. So that's what is happening here in the on enter. Remember, we're creating the goal, the spin goal, and then the goal takes in the angle and then the speed at which it should turn. Then we pass in all those parameters. And then we set the error checks to false, and then we use a try catch over here to prevent any ugly errors that might show up. So we send the goal, and if it failed, we set this error check over here so that we can know that it failed inside the execute function. Right, we're doing that. And then inside the execute function, what is happening is we're checking, did it fail to send the goal? No, it didn't. Then we move on. We check self.client.has results. So when you're using the action client, the proxy action client, there are a few methods that you can, when you have the time, you can look at the GitHub page. I think I have it opened here, yeah. And then it provides a lot more details about the methods that are available in the action client, the proxy action client class. But in our case here, we are using the has result and then has feedback. So has result, you pass in the topic to check if there is, we only have a result when the server is done processing the data. So here we are checking, do we have results from the server, the action server that is done? If we have, then we check it. Did it return a done or a failed? If it did return something like done, then we also return an outcome done, that, hey, I did what you asked, I'm done with you. If it didn't, then we're saying it failed, and then we also return an outcome of failed. Remember, this class that we're doing return two outcomes, a done and then a failed. Great. So if it hasn't finished processing our action, the goal that we sent, we can also be checking for, assuming your action server actually broadcast some sort of feedback. Well, this action server we're using does. So it broadcasts the current heading of the robot. So we're checking here, is there feedback from the proxy action, the server that we are using? If there's feedback, well, then we log in that feedback using the logger, the log info. Remember, this logger class is just a build up on the ROS .log info that we've been using in ROS as usual. Okay, then in the on exit, when we're leaving the state, what do? We check that if you see sometimes the on exit is called when the action actually didn't finish, the server didn't finish processing the goal. Sometimes we terminate it manually. Well, so we check inside the on exit that is the server still processing? Has the results returned? If not, then we cancel the goal so that the robot doesn't show any sort of misbehavior, like it's still processing the goal when the behavior has already ended. And then in the on start, here we just log in some sort of basic information to show that, hey, this state loaded correctly. So we're doing robot 10 state ready. Then in the on stop, we're also doing the same thing as we're doing in the on exit. Remember, the unstop is called on all states in the behavior. We're doing the same thing. We are checking if the action server is still working. If it is, then we cancel it. That's what we're doing. If not, if it is, then we cancel it and then we log some sort of information that, hey, I canceled the active spin action goal. All right. So if you've been following closely, this is the class that you should have present. But right now, I'm going to copy this, and then we're going to be creating this class inside the ID. So go to the same folder, the TurtleBot underscore FlexBe underscore state folder that we were using from the last class, and then right click here and then hit new file. Remember, we're calling the file 10 underscore state.py. Hit enter, double click to open it, and you can click on the tab over here to hide the list. So hit Control V to paste the code over here. So as usual, the code initializes in here. We're importing the various libraries. Then remember, for a state to be a state, it needs to inherit from the event state class, which is provided by the FlexBe core. All right. Then we're doing the how do we call it, the documentation for this class, so that anytime you see this state inside of the FlexBe graphical user interface, you know what it does. So you were saying it avoids obstacles, implements a couple of basic obstacle avoidance algorithms. Here, what it's doing is it's just turning the robot to whatever angle we send it, and then the outcomes that can be returned from it. Okay, great. So far, so good. So we've looked at the execute functions, looked at the on enter event, the on exit, the on start, and the on stop. So remember to save this, and then we'll move on to actually running this in a live session, because that is all what this class is about, to be running your projects live, to test it, and then to know that everything works. All right, so what we're going to do here right now is bring up the simulation. We're using the TurtleBot 2 simulation. So click on the simulations drop down and scroll to the very last one, TurtleBot 2. I'm going to click on it to bring this interface. Where's my notebook? Okay, let me drag you somewhere. Okay, so with our simulation run, this is what we're going to do. In any one of your terminals, okay, you remember we have 2 terminals. If you don't, just go to the tools drop down and then click on shell to create a new terminal. Right now, we're going to source the simulation workspace so that we can run the action server. All right, so I'm going to copy this code over here, Control C, and then in my terminal, I'm going to paste it and hit enter. It's going to take some time, but yeah, it worked. All right, so to bring up the server, first thing you have to do is we're using a ROS run. We could have created a launch file for this, but we didn't, so we start with ROS run. So we're using ROS run, and then the project is called Vision Follower, and then the server name spin underscore server.py, Control C, and then in that same terminal where you just sourced the simulation workspace, you paste it over there and hit enter. If everything goes right, you should see some log messages from the server. Yeah, the spin server started. That's great. So far, so good. Yeah. Okay, so you can hide this server because we will not be touching it again. You can hide the terminal itself. And then in another terminal, this is what we're going to do. Let me check if there are any. Okay, I could not open an error message. The project is copied, but Jupyter Notebook does not open. Tanja, I think you can just restart. Just go up here and then click on restart the tab, the browser tab that you have. It should work out for you. Sometimes these things happen. It's just probably due to the internet connection or something of that sort. For reference, ROS project open for me. Okay, yeah. So Tanya, try to restart the ROS development studio and then get back to us. Tell us if it still doesn't work out for you. Then we'll see what we can do from there. All right. So next up, we're going to use FlexBe. All right, so like we did the last time, remember to source the cartoon workspace before you run FlexBe. And that's what we're going to do over here. So you copy the code, the source cartoon / devel / setup.bash, sorry. So we do a Control C. And then in the new terminal that you open, you paste it over here. Well, whilst the cartoon workspace is being sourced, This is what you do. Go to the next command that we have, that's ROS launch FlexBe underscore app. And then we copy this command. This is the actual command that brings up, sorry, that brings up the FlexBe graphical user interface. So Control C, and then do a Control V in the same terminal. Okay. So provided there are no errors, well, FlexB should be up somewhere, but where is it? We don't know. Yeah. All right. To view the graphical user interface, go to the tools drop down and then click on graphical tools. Okay. Graphical tools. So I'm going to do that. But in order to, have, if you get this error like invalid login, just click on login again to reattempt and hopefully it works out. All right, in order to gain much space for me, you can click on this overlapping rectangles to open the graphical interface in a new tab. Okay, when you do that, remember to close the one you have here. So in my new tab, like I did earlier, just click on login to re-enter the whole interface again. So here we have it. Remember, we're using the turtlebot underscore FlexB underscore behaviors. Yeah, we created that behavior in the last class. So what we are doing is we are going to load in that behavior. It's a series, so we're just doing a continuous kind of development. We're not starting everything from scratch. So click on load behavior. And then remember last time we called it drive forward. So you just click on that to load in the behavior. Let's go to the state machine editor. And then, yeah, so this was what we had when we ended with the previous class. I hope everyone is on this interface before we start with today's implementation. Try to reopen the ROS. Okay, for reference. All right, so far so good. Sorry. All right, so we're going to add in the new state we created, the 10 state. So go to add state, and then you can choose the package, the specific package from which you want to fetch your state. So here I'm going to select the turtlebot underscore FlexB underscore state. And then I'm going to select the 10 state. Then you also have to give the new state that you're adding a name. So what do we call this? 10 around. Yeah, that should do. So we add this inside here. And let me close this panel for now. All right, so this is what we're going to do. We want the robot to travel a certain distance, right? And then there's this wall, this brick wall right in front of us. So what we're going to do is, if it fails, if it is not able to cover the specific distance that we gave it, well, what we're doing is we want to turn around. We want to turn a certain angle. We want the robot to turn in another direction and then try again. So how do we do this? Well, all you have to do is connect the failed outcome from the dry state to the turnaround state. And then you're going to connect the done from the turnaround. Remember the done outcome back to the dry state. So when the robot is able to turn that angle that we want to return back to the dry state to continue driving, to try again, to drive that specific distance that we wanted. So you connect it back, and then we have that. And also remember to connect the failed outcome to fail. So if everything else fails, just tell us, hey, I couldn't do what you wanted. I'm done with you. I'll move again. All right. But then you also remember that the 10 state actually takes some parameters. So let's go to the behavior dashboard and then create the parameters for the state. So just like we saw earlier in the previous class, we're going to select the type to be numeric, and then you give your parameter a name. I'm going to call this 10 angle, let's say 3, to differentiate it from the one we have there. Even you can use the same name, it makes no difference because we're using a self dot, which actually distinguishes the two. So I'm going to keep this self underscore 10 angle underscore 3. Hit on add, and then click on the pencil icon here to edit the variable you created. So here I'm going to set the minimum to 90 and then the maximum to 90. I'm going to leave the default value at 0, okay? All right, so click on the return icon to go back to the interface and then create the other parameter that we left with. So just like we did, you select the numeric type and then you do, I'm going to call this a turn speed. So the speed at which the robot should turn around or turn to the specific angle we want. All right, I'm going to leave this within a range of 0 and 1. And then I'll be setting the speed to 0.4. Looks like a fair value for me. Okay, so we're done with that. You can go back to the state machine editor interface and then let's set in the parameters. I mean, let's map it to those that we need to actually run the 10 state class. So what are we going to do here? Start typing the name for your parameter and then just once it is highlighted here, we want the 10 angle and then you hit enter to just load it in. I mean, saves us the time for typing and everything. All right, so you do the same thing for the speed. You select the 10 underscore speed and hit enter. Remember to hit apply over here to apply the changes we just did. And you can close the panel. All right, so far so good, but then let's try saving the behavior. If it saves successfully, means there were no errors, and then there is a high probability that the behavior might actually work. So you click on save and everything went as planned. Great. Let's go to the runtime control interface and then let's just test the logic we just created. Okay. So we're over here and remember to set the angle. You know, 0 is actually nothing. The robot doesn't know what to do with a 0, 10. So here I want my robot to turn, make a 90-degree turn when that state is entered. All right, so with the same values from the previous class, the obstacle distance at 1.5, the distance to travel at 0.35, and then my speed at 0.4, I mean, which is exactly the same as the 10 speed. So we could have actually used my speed, I mean, the one we have over here, for the 10 speed parameter, but we didn't, but we could have. Okay, so let me check the simulation. Let me actually make it bigger so that we see what happens. Okay, so the robot is facing the wall. I'm going to drag it back a couple more meters so that we can have enough time to observe the whole thing happen. Okay, so you click on start execution and then let's see the logic we just created. So the robot is going to start moving. Great, the robot is moving. And then here you can observe the logs, this obstacle distance reducing. When it hits anything below 1.5, it transitions to a failed state. And then in the failed state, which actually caused our turnaround state, you see the robot just made a 90-degree turn for us over here. And then last message is not now. Okay, something happened. I'm going to have to take a look at that. All right, so like the logic we defined, let me go up before we had that red arrow. Okay, so you remember when the state, the obstacle distance reached something like 1.5, that was when it transitioned into the failed state, like we have over here. It transitions into the failed state, and then in the failed state, that's where the turn state is called. So which does the necessary turning for the robot, and then moves back to the drive state, and then tries to move around again. So we had this error. Let me see what the error was about. And it says, last message is not none. All right, 9153, go forward. Okay, so let's see, probably due to the modifications I just made, might have missed something. Says line 42. Okay, so yeah, we're checking if it has message and then just doing this remove last message thing. At the moment, let me comment this line out so that when it comes back, probably the subscriber cache hadn't, well, we are not using the buffer. If we're using a buffer for it, the buffer actually caches all the messages, the previous messages, the past messages that we didn't process. So actually coming back here wouldn't have been much of a problem, but right now we're not using it. And so removing the last message is actually bad for us. So I'm going to comment this out. And remember, since I've modified this class, you need to actually restart the FlexBe interface so that it takes effect. So what are we going to do? Where are you? Where's my graphical interface? Well, remember you saved the behavior. And then inside the terminal here, I'm just going to do a Control C to terminate it and then bring it up again. Okay, so let's get back to the notebook. Let me check if there are any questions. Please, if you have any questions, feel free to post it in the chat section and then we'll see what we can do about it. Okay, great. So this is what I've been explaining so far. The behavior we'll be creating, what you should have, the final, executions that should show up for you. All right, so what is next? Today's class, remember we had two targets, the autonomy levels. Yeah. Okay. Also, there's one more thing I'd like to talk about. Today, our CEO being so good, we've been presented with a discount, which will be posted in the chat session. So if you're here, today's your lucky day. You can actually use this discount on the Robotics Ignite platform it's a 10% discount. So any course that you like to do on the Robotics Ignite platform, you can use it. And remember, the discount has a 24-hour expiry date. So you have from now to the same time tomorrow to use the discount. All right. So let's go to the autonomy levels in FlexBe. All right, autonomy levels. What is it about? So just as the name goes, this allows the operator, while having complete control over the robot's behavior, also gives the robot some sort of autonomy. So, well, it's pretty confusing. That we allow the robot to take its own decisions, even though some of the decisions, very critical ones, we want the robot to report to the operator, whoever is operating the interface, that, hey, I want to do this. Are you going to allow me or not? So let's go back to the interface. Hopefully it's up again. And then let's load in the behavior we've been working with. So the drive forward. So let's go to the state machine editor. I'm really hoping we don't get another error over here. Okay, so how do we use the autonomy levels? This is actually very simple. So click on the state for which you want to set an autonomy level for. So in this case, the most logical one here is the turnaround because it does something and then it goes back to the drive state. So what we want to do is we want to monitor when it is done turning around. So when it is done turning the specific angle that we wanted to tell us, hey, operator, I'm done making a 90-degree turn. What do you want me to do? Should I go back to the drive state? Or should I wait for some time? Until you allow me, I can move on. So here, what we're going to do is we'll be setting the autonomy level for the done outcome. All right, so remember we have 3 levels over here. By default is off. We have low, high, and then full. Low and high are just 2 different levels of some sort of autonomy level, but then the full actually, when you use the full autonomy here, what you're doing is it shouldn't report to you, the operator. The robot should just move on and do whatever it is doing. So in order to demonstrate this very well, I'm not going to use the full autonomy level. I'll be using low. You can use high, but then it depends on also another variable that we'll be setting in the runtime control interface. So I'm going to set this to, let me set it to a high. Yeah. And then remember to click on apply and then close the panel. So you go to the runtime control interface, and before you actually run the whole behavior, remember this is where you get to set which kind of autonomy level you're going to monitor. So what is happening here? Load behavior. Yeah. Okay, my behavior is loaded, runtime control interface. Yeah. Okay, so let me go back and then do this again. Yeah, I forgot to save. That was the problem. Okay, so remember to set after setting the autonomy levels, remember to say, in fact, after doing anything in the state machine at the time, remember to save, else the runtime control is not going to give you that interface to do whatever you want to do. So apply, you close the panel, and then you save the behavior. Now let's go to the runtime control interface phase, and then all things being so good. Yeah, we have it. Okay, so I'm going to set the angle back to 90 degrees so that the robot will make a 90. And then let's move our attention over here. It says block transitions which require at least. So this is where you set the kind of autonomy level that you, the operator, will be expecting. So in this case, we have the autonomy level is set to a high. So with if we can maintain a low and then it'll still block for us because at least low is actually less than high. So at least low means if it encounters anything higher in the hierarchy, it's supposed to block. All right. So I can leave it at low, you can leave it at high, but then remember when you said the at least high, that means anything that is on a low autonomy level will not be blocked. Okay. All right. So I'm going to leave this at high so that probably we have a low autonomy level somewhere. I'm not sure. I'm really confident there's none, but let's set this to high. All right. Let me go back to the simulation and then make sure the robot is reconfigured to its initial pose. I mean, the initial pose that it had before we started so that we can relive this whole experience again. So remember to hit the arrow icon when you're done resetting the robot, because if you leave it like this, the changes are yet to take effect. So remember to click on the arrow icon when you're using the Gazebo interface here on the ROS Development Studio. Okay, so with the robot ready in place for us, let me check. Do we have any questions? First, thank you. It's my first time watching. If I pass through the past 26 videos, can I catch it? Yeah, sure. Yeah. I mean, yeah. So you don't necessarily have to pass through the past 26 videos. This series actually started with last week's class. Yeah. So if you're interested in the FlexBe engine, you can just go back to last week's class and then you can catch up with us right away before the last class for next week. That is from Halil. I hope your question is answered. But then if you want to gain much more experience on what we've been doing till now, yeah, I think I recommend you start from the first live class and then hopefully we catch up with us before we're done with this series. So I'm going to go to the Robot Ignite graphical interface, and then we're going to run the behavior again. Remember, we've set the autonomy level, so when the robot is done making the turn, it's supposed to report back to the operator. So you click on start execution, and then, yep, the robot is now moving. So you see here, in fact, for this time, let's observe the robot in the gazebo interface. So it moves, and then when it reaches that obstacle distance limit, it's supposed to make the turn that we want it to do. But then observe something here. When it is done making the turn, remember, you see that this transition here is highlighted. It means it's waiting for you to actually give it a go ahead. So that is actually the main function of the autonomy levels that we've been talking about till now. What we're doing is, hey, I'm done turning, making that 90-degree turn. Are you going to allow me to transition back to the drive state? If so, you just click on this and then it will do that for you, okay? But then you can also click on, hey, fail, don't continue and just return a failed outcome. You can just click on any of the outcomes to force it. But then what autonomy levels does for you is it allows, it pauses the whole behavior until the operator says move on. So right now I'm going to click on the done state, and hopefully if we don't have, well, this error is really bad. It's not making me look good. So I'm going to return the class to what it was before, and then I'll take a look at this once we're done. So previously we're just doing a self, we're checking if self.data is not none. Okay, and then remember to activate the subscriber that we're using here. Actually worked with this before the class. Everything worked very nicely. I don't know why I'm getting these errors. But then for the sake of this class, just reset everything back to the way it was. So you comment out these two and then just do the self.data is not none check. And then remember to reactivate the callback that we're using. So with that done, I'm going to restart the FlexBe interface. Really, I apologize for this. I really didn't see this coming. All right. So just bring it up again. ROS launch, FlexBe app, FlexBe underscore full.launch. So let me check. Do we have any questions? Well, I hope everybody is following. So I'm going to go to the graphical user interface. And then, wow, the time is actually fast spent, but we're almost done. So just click on load behavior to load the behavior we created. Remember, we did set the autonomy level for this. So let's just check. You see that the highlight over here is different. All right. So let's go to the runtime interface and then let me just reposition this robot. And I really hope we don't get another error on this so that you see, how awesome this behavior looks right now. So back to the interface, remember to set the angle. I'm setting it to 90. And then, we're blocking transitions which are at least low, which works the same way for us. But I'm going to set it to high. You can leave it at low. It will block it because it's at least. So, all right, I'm going to click on start execution. And then we wait. So here we're observing the obstacle distance right now 2.8, 2.7. The moment it goes anything below 1.5, it transitions to the turnaround, which when it is done, when this transition fires, it's supposed to wait for us. So now it is done and then it's waiting for the operator interaction. So I'm going to click here and yes, now everything what you see, it turned and then it went back to the drive state again and continue on driving. So like this is going to drive until it encounters another obstacle all until the distance that we set for it. Remember the previous class, we wanted to actually move a certain distance. So it's going to keep moving until it's made that distance or until it encounters some sort of obstacle. So without much ado, this is it for today's class. Remember, we looked at proxy action clients, and when you're using a proxy action client, always, it's recommended to always create the goal in the on enter event and then call the goal over there because it actually gives us some sort of asynchronous sort of behavior. So we did that. And then in the execute function, that is where we monitor. In the execute, that is where we check has the server returned whatever we asked it to do. Did it return an error? Was everything successful? And then we're also returning if the action server actually gives some sort of feedback, you can be calling that feedback over here. Okay, so the action client, you create your goal in the on enter event, and then you actually call the goal. You send the goal over there inside the same event, and then you monitor it in the execute. So that's just the different thing that we did. With respect to the previous classes, with the previous proxy classes that we've looked at so far. And we also looked at the autonomy levels and then the various ones that you can use. Yes, in the robot, when you come over here to the graphical user interface, if you set this to full, means you're giving the bot a full autonomy. And then, well, here we're saying requires at least full. So remember, we have it's a hierarchy. So low, high, full. Right now, if I set this to full, it's not going to block the autonomy level that we set because what we actually did set was a high. So, and high falls below full, so it will not be blocking it. So that's just it for the autonomy levels. But there's one more thing. For next week's class, I don't know if any of you have been reading around on FlexBe, and then if you want anything specifically to be tackled, because well, I have something in mind. I mean, we can look at the container types available in FlexBe. We have the priority containers, and we have the state machine, which we've been using so far. And then we have the concurrency containers, which actually allows you to run two or more behaviors in parallel, almost parallel. I mean, execution. So let me know if you're down with that, if you want us to do that for next week and the last of the series, or if you have something in mind, you can post it in the chat and then we will agree on something and do that for you. So you can pause the live video and rewind if you need to catch up. Oh yeah. Oh, thank you, Felix. Yeah, you can do that. I actually used to do that some time back. All right, so that's it for today's class. And then I'm waiting for your questions. I think we have 5 or 8 more minutes. So if you got lost anywhere along, I might have moved too fast. I mean, I remember someone. Yeah, I think who was it? Yeah, Halil. He said this was his first time, so I might have actually the interface. Man, it takes some time to get used to. So if you got lost anywhere along, you can just put your question here, and then we'll take care of it for you. So also remember to like and subscribe, I mean, to the channel, and then you can post any questions that comes up. I mean, even when the class is done, you can post your questions in the comment section, and then there is a whole team of very capable engineers who are going to attend to you. So I'm waiting for your questions. I think I have um, 4 minutes more. I'll be here. Let me know if you have any questions, if anything comes up. And remember, I said earlier that I had a chance to talk with Philip Schillinger, I mean, the creator of the FlexBe Engine. He says he's really available for anyone if you want to talk to him personally, if you have some kind of suggestions that you want to post, he's available for you, and then he can return all your emails. And I think, let me see if I can post. Well, you can go to the FlexView documentation, and then there you can find a form to actually send a query, which he does really well at responding to. So that's just by the way. So I'm still in the chat session, and then I'm waiting if there is any question. Wow, today's class really seemed awesome. I'm happy as well. Okay, so I think that will be it for today. And let's look forward to the next class. One more thing, Philip promises to do his best to actually be here for the next live class. So it's going to be awesome, man, because I gotta prepare like 3 4 because the creator of FlexBe himself is coming here. I look forward to seeing everyone come next week, and let's keep developing. Bye.